we said a matrices refers to as an arrangement of items, persons, or numbers in rows and columns. In real life, it may involve the arrangement of soldiers on a parade, the arrangement of cars in a park, and the arrangement of numbers in rows and columns. With these arrangements, we can compare, count, subtract, or perform other higher algebraic processes. By the definition, we said a metric is an arrangement of numbers, but listeners and viewers should know that these numbers can be real numbers and can also be complex numbers. And these numbers are arranged in rows and columns to form a rectangular array. And the product of the numbers of rows and columns refers to the order of the metric. For example, a metric A, you should understand that a metric is denoted by a capital letter, while the element within the metric is in small letters. We have example A, a metric A equals to 1, 3, 2, and 4. Now the arrangement of these numbers, the vertical arrangements are referred to as the column, while the horizontal arrangement are referred to as the rows. In the above example, when you observe that the metric at the right-hand side, 1, 3, 2, 4, this metric has two columns. The first column is 1 and 2, and the second column is 3 and 4. We also have two rows, that is 1 and 3, and 2 and 4. Hence, this metric has two rows and 2 columns. Therefore, the order of this metric is 2 by 2 metric. Also, if metric M is given as A, B, C, D, and E, metric M has 2 rows, but it has 3 columns. Now the order of this metric is referred to as 2 by 3 metric. Reason? Because it has 2 rows and 2 columns. You first count the number of rows, then you count the number of columns. Therefore, in this metric, we have only 2 rows and 3 columns. Therefore, the order of this metric is 2 by 3 metric. Then we have types of metrics. It is of great importance to note that these are not only the type of matrices we have, but for the purpose of, this lesson, we are going to consider only 6 types of matrices, namely equal matrices, 2, square metric, 3, zero or null metric, 4, row metric, 5, column metric, and 6, identity or unit metric. 2 matrices A and B are said to be equal if they are in the same order and their corresponding elements are equal. Here, for 2 matrices to be equal, they must satisfy 2 conditions. The first condition, they must be in the same order. The second one, the corresponding element must be equal. When you look at metric A and metric B, the first element in metric A is 1. Likewise, that of metric B is also 1. The second element in metric A is 2, and that of metric B is also 2. Going to this second row, the first element in the second row is 3, while this, in metric B, the second row, first element is also 3. Then we have 4 and we have 4. Now looking at metric A and B, they are in the same elements. Likewise, their corresponding elements are equal. Finally, you can deduce that metric A is equals to metric B. But hence, students should note, or listeners and viewers should note, if we have metric R as 1, 2, 3, and 4, and metric S, 1, 3, 2, and 4, metric R is not equal to metric S because metric in the first, the element in the first row, that is second element in the first row, which is 2, is not the same as the second element in first row of metric S. Therefore, due to this reason that the corresponding elements are not equal, hence metric R is not equal to metric S. Since R12, meaning number in the first row, second column, that is 2. Number in the first row, second column, which is 2, is not the same as number in the first row, second column of metric S. Therefore, these metric are not the same. That is, they are not equal. Metric S is not the same thing as metric R. Square metric. A metric whose number of rows is equal to the number of columns is called a square metric. For example, we said let y equals to 3, minus 1, 0, and 2. If you observe this metric clearly, it has 2 rows and it also has 2 columns. Therefore, the number of metric is the number of columns is the same as the number of rows. Therefore, this is called a 2 by 2 square metric. You should note it is of great importance. When naming a metric, you should start with the order of the metric. That is why we said this metric y is 2 by 2 square metric. 2 by 2 is the order, while square metric is the type of the metric. The same thing in metric Z. We have A, B, C, D, E, F, G, H, and I. And this has 3 rows and 3 columns. Therefore, the order is 3 by 3. Type is called a square metric. So this is called a 3 by 3 square metric. Then next is 0 or null matrices. 0 or null matrices is just a metric where all the elements or all the entries within that metric is 0. Simple as that. Example, we have a metric 0, 0, and 0. It has 2 rows and 2 columns. Therefore, it is a 2 by 2 0 metric. Then next is row metric. A row metric is a metric that has a single row of elements, irrespective of the number of columns. As long as the number of rows is 1, then it is referred to as row metric. Example, we have a metric X, Y, Z, or 1, 2, 3. These 2 matrices has 1 rows but 3 columns. Therefore, it is called 1 by 3 row metric. Then column metric. Column metric, this is a metric with only 1 single column of element. That is 1 column of element. Example, Y is a metric of elements minus 2, 0, 3. It has only 1 column of elements, but 3 rows. Our priority is in the number of columns. So it has only it has 1 column. Therefore, it is called 3 by 1 column metric. Lastly is what? Is the identity or unit metric. Other textbooks call it identity metric. That identity metric is denoted by capital letter I. So in example, the first one, I, which is identity metric, equals to 1, 0, 0, 1. If you observe this metric, the diagonal entries is 1. Therefore, this is referred to as 2 by 2 unit metric or 2 by 2 identity metric. And also, if we consider the next example, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, it is an identity metric of order 3. That is 3 by 3 unit or identity metric. Next is the basic operations under matrices. We are to start with addition and subtraction of matrices. Under addition, we said 2 matrices A and B can be added or subtracted if they are in the same order. That is, if the number of rows is the same as the number of columns. What I'm saying here is that the number or the order of metric A must be equal to the order of metric B. Meaning, if metric A has 2 rows, metric B should also have 2 rows. If it has 2 columns, metric A, metric B likewise must have 2 columns. With this, you can perform addition or subtraction of metric A and B. Example, if metric A is 1, 2, 3, and minus 4, metric B is 1, 2, 5, and minus 3. Find 1, A plus B, 2, A minus B. Solution, first is A plus B. All you need to do is to bring metric A and I add it with metric B. Metric A is 1, 2, 3, and minus 4, plus metric B, which is 1, 2, 5, and minus 3. Now, you can only do that by adding or subtracting their corresponding elements. That is, in metric A, the first element there is 1. So we have 1 plus 1. Then next is 2 plus 2. That is 2 in metric A plus 2 in metric B, corresponding elements. Next is 3 plus 5. Then minus 4 plus minus 3. And next step is when you add 1 plus 1, you have 2. 2 plus 2, you have 4. 3 plus 5 is 8. And minus 4 minus 3, you have minus 7, as simple as that. Then second example is to find A minus B. Do the same as the way you did in the first example. There we add. Now we are going to subtract. Still you subtract their corresponding elements. That is 1 minus 1. 2 in metric A minus 2 in metric B. 3 in metric A minus 5 in metric B. Then minus 4 in metric A minus 3. Students should take notes. The first minus there is for the subtraction of A and B, while the second minus there is for the element. So therefore, when you set 1 minus 1, you have 0. 2 minus 2 is 0. 3 minus 5 is minus 2. Then minus 4 minus 3. Minus 3 will now change to positive sign. Therefore, you have minus 4 plus 3, which is the same as minus 1. Next is scalar multiplication. We said let A be an m by n metric. What do you mean by m by n? M is the number of rows, while n is the number of columns. And let C be a scalar. The product C and A, that is C times A, is called a scalar multiplication. Meaning, the number multiplying a metric is called the scalar. For example, we have y equals to 4, 2, 0, and 1. And we have to find 3y. 3 there is the scalar because it's multiplying metric y. So in this regard, all you need to do is to multiply 3, which is the scalar, times the given metric, which is y. So therefore, we have 3, the scalar, will multiply each and every element within metric y. That is 3 times 4, 3 times 4, next 3 times 2, then 3 times 0, and 3 times 1. Now 3 times 4 will give you 12. 3 times 2 will give you 6. 3 times 0 is 0. Then 3 times 1 is 1. Simple as ABC. Next is multiplication of matrices. So 2 matrices A and B can be multiplied together as AB only when the number of columns of metric A is equal to the number of rows in metric B. Listeners and viewers should take notes. Multiplication of matrices is not the same as scalar multiplication. It's not the same as addition. It's not the same as subtraction. Because we said for 2 matrices to multiply together, the number of columns in the first metric must be equal to the number of rows in the second metric. For example, we said let A equals to 3, 2, 1, and 4. Metric B is 2, minus 1, 0, and 3. We are asked to find AB, that is A times B. Now, the first step is to write the multiplication of these 2 matrices, that is A and B. Now, the corresponding elements are not going to multiply themselves. No. What you need to do in multiplication of matrices, the first row will multiply the first row of metric A, will multiply the first column of metric B, then first row of metric A still will multiply the second column of metric B, then you now take second row of metric A multiplied by the first column of metric B, then still second row of metric B times second row of second column of metric A. Just as it is, the first element in first row of A is 3, then times 2, which is the first element in first column of what? Of metric B. Then you have 3 times 2, which is the first element, then 2 times 0, that is second element in first row of metric A, times the second element of first column of metric B. Then plus first row, second column, that is first element in metric A times first element in second column of metric B, that is 3, that is 2 times 3 times minus 1. Next is 2 times 3, which is the second number. Then next is second row, first column, second row, second column. Second row of metric A times first column of metric B, second row of metric A times second column of metric B. That is 1 times 2. It's here 1 times 2. Then next is 4 times 0. 1 times 2 plus 4 times 0. Next is second row, second column. That is 1 times minus 1 plus 4 times 3. Upon multiplication, when we multiply 3 times 2, we'll have 6. 2 times 0 is 0. 3 times minus 1 is minus 3. 2 times 3 is 6. 1 times 2 is 2. 4 times 0 is 0. 1 times minus 1 is minus 1. 4 times 3 is 12. Next, we'll do addition of matrices. That is 2 plus 0, 6 plus 0, we have 6. Minus 3 plus 6 is 3. 2 plus 0 is 2. And minus 1 plus 12 is 11. That is the result of the multiplication. To end this lesson, I have some assignment for the viewers. The first one is find a metric and give 2 examples of metrics. 2, given metric Q, 1, 2, 3, 4, 5, and 6. State the order of Q, that is metric Q. 3, given metric A as 1, 2, 2, and 3, metric B is 2, minus 1, 0, and 1. Find 1, A plus B, 2, A minus B, 3, 2A, and 4, AB. Thank you for listening.